Alright, tonight what we're going to be talking about is the activity series. And the activity series is a special table that you use for single replacement reactions. Not every single replacement reaction goes, and in order for it to go, the element by itself has to want to be a part of a compound more than the element it's trying to kick out. Everybody wants a full octet, and how elements do that is that they combine with other elements so that they can give or gain or lose or take or whatever they need to do in order to get that full octet. But the element by itself has to be higher and want it more than the element it's kicking out, because in that process the element that it kicks out will no longer have an octet like it really wants. So the activity series determines whether one element will displace another element in that compound. So how can you tell if an element will replace it? Well, the single element must be higher on the activity series, meaning it has more of a desire to get that octet and be a part of a compound than the element that it's trying to displace. If it is not higher, then what you write is NR, so that you're relaying the information that no reaction would actually occur. This is what the activity series looks like, and you'll notice on the left you are dealing with the metals, so metals will only kick out other metals. So if I were comparing lithium, right here, lithium would be able to kick out any other metal below it as far as how reactive it is. So lithium wants to be a part of a compound more than almost any other element according to this activity series, and it would always be able to kick out an element that is in a compound. If you look at the nonmetals, you're basically talking about only the halogens, and so in this case F would be able to kick out chlorine that's in a compound, or bromine, or iodine. Any one below it, it has the ability to kick it out. So let's just try some problems. Would these reactions occur? So what you want to do for single replacement reactions is you always want to check the activity series and see if this reaction would actually occur. So you need to check, is Ag higher, which is the element by itself, higher than Cu, which it would be trying to kick out? Because once again, everybody wants that octet, which it would get by being a part of a compound, but Cu no longer would have that octet, so Ag would need it more, or want it more than Cu in order for this reaction to occur. So all you need to do is you need to look up Ag, which is right here, and it would need to be higher than Cu, which is right above it. So this reaction would not occur because Ag is not higher than Cu. In the next case with magnesium sulfate, or MgSO4, and I'm comparing it with zinc, I would need to be checking zinc. Zinc is the element by itself, and what would it be trying to kick out? Well, zinc is a metal, so it's going to try to kick out another metal. So it's going to try to kick out that magnesium. So what I'm going to need to do is now look on the activity series. Zinc needs to be higher on the activity series, which is right here, than magnesium. And magnesium is above it. So would this reaction occur? No, it would not, because zinc is not higher on the activity series than magnesium. Alright, so let's try to predict the products. With single replacement reactions, if you are expected to try to predict the products, you always want to check the activity series to see if the reaction would actually occur. So in this case, I would be comparing Cu, which is a metal, to zinc, which is another metal. Cu is the metal right here, and it would need to be higher than the zinc that it is trying to kick out. And in this case, it is not higher, so all you would have to do is you would have to write down no reaction. So if I had a copper bowl or dish, it would be able to hold zinc nitrate in it, because that copper would never react with the zinc nitrate. Even though it would want to be a part of, be bonded with the nitrate, it would not have that ability because it is not higher on the activity series. Alright, let's try to look at this one. So we've got Br2, which is a nonmetal. So what we're going to have to do is look at the nonmetal list, and we're going to compare it to the other nonmetal in NaCl. And Cl is your nonmetal in this case. So I'm going to look at Br. Br is actually lower once again than Cl. So this reaction too, you would write no reaction. Alright, so then we're going to try this one. So this single replacement, the element by itself is Br, which is right here, and it is going to be trying to kick out the other nonmetal, which is I. In this case, it actually is able to kick it out because Br is higher than the I that it is trying to kick out. So what's going to happen is Br is going to kick out that I, like that, and now we have Na, and Br will be where I was, so we're going to write Br, and then now I will be by itself. Now we have created a new compound in NaBr, so once again we're going to have to worry about CCC, which is compounds. Okay, now we need to worry about our charges, which is +1 for Na. Br has a -1, so when we crisscross our charges, they are going to reduce and cancel. All right, the next thing we need to do is worry about our I. I is a Hunkelbreath, and so we're going to need to put a 2 to make it the diatomic molecule that it is. And the last thing that we're going to need to do is we're going to need to balance it. So you put a 2 in front of the NaBr, and then you're going to put a 2 in front of the NaI. All right, hopefully you have a basic understanding of activity series. Remember that you only use them for single replacement reaction, and the element by itself has to be higher than the element it is trying to kick out in order for the reaction to occur. If it is, then you need to be able to predict the products, and if it is not, all you have to do is write NR.